Hello, Qiskiters! I'm Abby Mitchell, and I'm a quantum developer advocate on the Qiskit community team. In our last video, we covered the basics for how to publish your quantum code on GitHub and also how to cite it in your research papers. So in this video, now we're going to explain some different ways to make your open source code better for those who may want to use it. So we're going to explore some best practices, as well as how to submit your project to join the Qiskit ecosystem. Okay, so we're going to start with, let's talk about some tips for making good open source projects. Number one, make it as easy as possible for others to use your code. There are a few different things that you can do here. Make sure in your GitHub project, you've added a description. You can also add a file called a README, which is the file that will show up on the front page of your GitHub repository. And this is a place where you can clearly explain how to install the project, how to use the code, and also consider explaining to other researchers in your README how you would like them to cite your project if they decide to use it for a paper that they're writing. You can also add a license. This is a way to kind of add some slightly more legal phrasing around how you want others to use and interact with your code. And if you're on the more advanced side of things, if your project is quite big and you have lots of collaborators on it, you can think about adding milestones and releases as a way to kind of show your users how your code is progressing over time, and if you have a regular release schedule, so they can see what's going to happen a while in advance. Second of all, you want to make your code as easy as possible for people to understand when they are reading the code itself. So to do this, what you want to do is you want to make sure that your code is really tidy. You want to remove any print statements. You want to possibly add comments into your code explaining the logic. You should also document your code. So in Python, that means adding doc strings to any of the public-facing classes and functions. And just generally make your code kind of as easy as possible to read when you're actually looking at the code itself. The next thing that you can do is also you want to ensure that your code is reliable so that people that are using it don't have to worry about it breaking all of a sudden. To do this, what you can do is you can add unit tests. For Python, there are a few different testing libraries like unit tests or PyTest. You want to choose one that that is best for your project. One step beyond this is to start also running continuous integration and continuous development, or CI/CD. If you're not familiar with CI/CD, this is essentially the process of automating your test runs every time that you, for example, push something to your main branch, or every time you do a deployment. You can run a series of automated tests. You can try using different versions of Python, those kinds of things. And it's a way of kind of doing that regular testing to keep things working over time. And then you can more easily see if someone introduces a new piece of code that breaks something. You should be able to see that when they open a PR or where they push something into main. There are a few different kind of providers that you can use to set up your CI/CD, such as Travis, Jenkins. GitHub Actions is one of the newer ones, which is quite nicely integrated within GitHub itself. And yeah, that's a slightly more advanced way of testing your code and keeping it reliable for your users. Number 4, I think, we're on now, of how you can, some best practices for open sourcing your code is the aspect of engaging with your community. There are a few different things you can do to make your open source repository more essentially collaborative and more open to contributions from the community. You can, for example, set up issues and pull requests, as well as a branching strategy. You can add a discussion tab into your GitHub repository just for those more kind of casual interactions. And you can also nominate your project to join different high-profile collections that are designed to highlight projects, such as Awesome Lists or the Qiskit Ecosystem. Okay, so I just went through a long list of lots of different things there. If you feel a little bit overwhelmed by everything that I listed out and you don't really know where to start, you can also have a look at some GitHub templates. There are lots out there. They're basically templates that you can use to set up a project. They will give you kind of a basic folder structure and some guidance around how to make a good quality project. I particularly want to highlight one that I have here within the Qiskit community called the Quantum Prototype template. And this gives you some really nice kind of structures for different files you might want, ways to document your code, ways to run tests, things like that. It's a really helpful kind of boilerplate for if you're just getting started and you want to make really high quality open source projects. And we'll put links in the descriptions for that. Now, with all of that in mind that I just mentioned, I'm going to go through with you today just a few of those things that will help make the project, this My Cool project that we set up in the last video. We're going to go through a few steps based on the things that I mentioned just now in order to kind of improve the quality of this project a bit to a point where we could then submit it as an issue for, submit it as an application for it to join the Qiskit ecosystem. So in order to have our project join the Qiskit ecosystem, there are a few extra things that we need. If we want to have tests configured, we need to have a structure where we have a test folder with tests in it. We also need to specify a requirements file. And we also need to add a license to our code. So we're going to go through some basics on how to get that started. And as well as that, we're also going to add a README file to my cool project so that you can see how to do that as well, because that's a really nice, essentially, landing page for your repository when people first hit your project. Okay, so coming to our screen here, I have my project on the right. I have on the left, I have the code set up. You might remember this from the last video we did. And I have my terminal here where I'm going to run my Git commands. So the first thing that I did, which is always good practice to do if you are coming to make changes in a project, is I'm just gonna fetch and pull data from my GitHub repository that is hosted in GitHub, just to be sure that in case someone else had pushed something, made changes to the version that was hosted in GitHub, I want to make sure that those changes are reflected here on my project that I have locally. In this instance, I'm 99% sure that no one has done anything because this is my own project. No one else has added anything to it, but this is good practice, especially if you have a lot of other people working on your project with you. So to do this, I'm first going to run git fetch. And it didn't output anything because there was nothing for me to fetch. And I'm also going to run git pull as well. Main. And I'm going to specify that I'm pulling from the main branch. It will already default to pull from the main branch, but I just like to specify it for my own sanity because it's very easy to accidentally pull from the wrong branch if you have multiple branches set up in your repository. And yeah, you can see it's pulled from the main branch, and it even tells me that it's already up to date. Git fetch and git pull serve slightly different functions. Git fetch will kind of do more of like a shallow fetching of information. It tends to just get any new branches that were created, things at that level. Whereas git pull will actually pull any individual file changes that were made. And if you can go and check the Git documentation if you want a more detailed breakdown of the difference between those commands, we'll add the links in the description. Okay, so now that we've fetched and we've pulled, we're pretty sure that we have that the version of our code that we have locally is the most up to date. Nothing has been changed to these files that we had hosted in GitHub. Next, what we're going to do is we're going to edit these files. I'm going to start off with adding a README file, which is all caps readme.md. This stands for Markdown. Markdown is a specific kind of language for essentially writing text documents, and it gives you some extra nice features that you can use to kind of format things nicely. And GitHub uses a particular type of Markdown called GitHub flavored Markdown. It's pretty easy to Google the different syntaxes for that, but I'm just going to add a heading here with this kind of hash symbol, means that I have the main title, and I'm just going to call this my cool project. And then within this, you can really explain whatever you need to explain. It's really at your discretion what you put in here. It's always a good idea to explain to people what your project is about and how they can get started installing it, any links that you might need to send them to other resources to help you with. And yeah, there's a lot of things that you can do with a README, and it really helps people if it's going to be the first page that they see to understand what your project is about. So I'm just going to say, this is going to be a very bad README, but I'm just going to say, this is my cool project. Project. I would be a much better developer if I could actually spell things correctly. But there we go. At the very basic, it's just like a bunch of text. You can maybe add some emojis or something if you want to. There's special text you can do to add the emojis if that's what you want to do. You can save it. And here we have our README that's added. So that's one thing that you've done. We'll add a link in the description for some articles on what things you can include in a README, what things you can do to make your README really impactful. And next, what we're going to do is focus on some of the other things that we need for joining the Qiskit ecosystem. One of which is a requirements file. So this requirements file.txt, I prepared in advance. This is just a file where you can list any packages, any pip installable packages that you need within your project to essentially run the project. And you can specify what versions you want. So in this example, I've just very basically said, in order for my cool project to run, I need Qiskit Terra and I need NumPy. It's very basic. It's just a .txt file extension, and it should live in the root. So that means like at the very highest level of your cool project folder. It shouldn't be hidden in a subfolder. It needs to be at the root level. And the next thing that we've also added here is a test folder. This test folder itself, again, should live at that root level. And within that, I just have one test file here. Most test files, depending on the testing framework you're using, should start with the word test and have a structure kind of like this. This test doesn't really do anything. It's just to show you the basic setup. You have some documentation. It asserts some things. Again, there's a lot of best practices around how to write good unit tests. We're not going to go into a lot of detail, but what you should know is you shouldn't just be writing tests for the sake of writing tests. So this example is actually a bad example because I did just write the test for the sake of writing a test to show you how to write a test. But you should think about when you're writing unit tests about what is the features that you have in your project that you want to test with different arguments, with different edge cases. Think of it from the perspective of like, what could go wrong with my code and how do I test that it's working as it should do? You also want to check if your code is going to throw errors for something. Check that those errors are being thrown in the way that you are expecting them to. Okay. So we have our test folder with a test, we have our README, we have our requirements file. So we have all these changes now, and we want to add them to our project. So what we're going to do, if you followed the previous video, this should be familiar to you. We're going to add all of these files to our staging area with git add, then just the full stop. Those should all be added. I work in VS Code, so I like to just double check everything here is added. It's adding this extra file that I don't really need. It's just some VS Code config things. So I can see these are the files that I have staged that I actually want to have committed and pushed. And then I'm going to just commit these, git commit -m. And I'm going to explain a bit what I've done. I've added a README, tests, and requirements. And then I'm gonna push it so that the work that I have here locally is then shared with the project that is hosted and published on GitHub. Git push origin main. And then we wait a minute. Okay, it's pushed. I should be able to refresh and it will be there. Yeah, there we go. And look, we have a README, a very bad README. But yeah, one cool feature of READMEs is that you can actually link to different headings within them. You can render tables, you can do images. This was just like a very basic one here. And yeah, so we have now our setup pretty much ready. There is one other thing that we need to add to have our project join the ecosystem, and that is that we need to add a license to our project. And this is something you can either do in a code-based way. It's just adding an extra file which specifies the license, but GitHub actually also offers you a way to do it directly here within the browser itself. So to do this, we're going to go to Add File. We're going to click Create New File. And then you want to add a file called license in all caps, license. And then you can see it pops up with a helpful prompt button here, choose a license template. And if you click on that, it comes up with a lot of different options. In your own time, you should have a look at these different licenses and think about which one is right for you and your project. We'll also add links in the description where you can find all this information. We're just going to go with an Apache license to start off with. And then I'm going to click Review, and that looks good to me. Yeah. And then it will kind of like pull in all of that license code for you. Then you can add a commit here. This is also a nice way to show how you can add files and add commits actually within the GitHub UI itself, which, you know, may or may not be something that you feel comfortable doing, but you can, if you want, do that. I'm just gonna add the commit message the same way I would, you know, in my terminal, but I'm just doing it now in the UI. License file. And it gives you an option if you want to commit it directly to your main branch or if you want to create a separate branch for it. I'm just going to commit to the main branch for the sake of simplicity. But yeah, as your project gets bigger and more complicated, you should consider using multiple branches to switch between different workflows that you're doing. I'm going to commit this. Ta-da! And you can see we have the license here. And now the last thing that we have to do is just submit this project to the Qiskit ecosystem. The main way to do this is we go to the Qiskit ecosystem repository here, which lives in the Qiskit community GitHub organization. The way to do this is, you can see they have a nice README here with instructions for how to join the ecosystem, more details as well about who's already in the ecosystem, what kind of testing you need. But if you just click this main link here, this will take you to the issue page. And all you need to do for this is really just put in a title for your submission, such as add my cool project to ecosystem. And then you want to paste the URL to your GitHub repo. So in my case, that's just this one. Submit it. You need to add a bit of a description and then you need to select which license that you've added. You can add a bunch more information here, which will all kind of get packaged up and used when we kind of present the projects on the main website. And yeah, it's pretty straightforward. You just fill this issue in. Once you've done that, you click Submit New Issue. Once you've submitted an issue, this will automatically open a pull request linked to your issue, and then a member of the ecosystem maintainer team will review that, and there might be a bit of back and forth, some improvements you need to do, and then once that is kind of approved, your project will get merged, and within 24 hours, you should be able to see it showing up on the Qiskit.org page, which I can show you just here. And you'll see a nice kind of tile appear with the title of your project, a bit of a description. If you run tests, then those will show up as well. And there you have it. Okay, so there we have it. That's how to do some of the best practices for making a good GitHub project, as well as how to prepare your project to join the Qiskit ecosystem. The examples that I've shown you here, again, have been quite superficial. So a project like mine with like one file that doesn't really do anything probably wouldn't end up in the ecosystem, but it was just a nice way to show you the mechanisms of how to do those things within GitHub, and where to go from there on through the process of applying to join the ecosystem. So this concludes our video on open source best practices, the Qiskit ecosystem, and also concludes our series as well on open sourcing your quantum code. Thank you very much for joining. Remember to like, subscribe, leave comments if you have any questions, and thank you very much.